We're going to do the practices for lesson 13, advanced networking. In these practices, we will configure network bonding by using a GUI and from the command line. And then we'll explore the bonding interface configuration. We'll configure VLAN tagging interfaces and then explore those. And then we'll configure a site-to-site VPN. Practice 13.1, we'll configure network bonding by using the GUI. So we'll view the network configuration on DOM0. We'll log into host 02 by using VNC Viewer. We'll view the network configuration on 02, and then we'll configure bonding on 02 by using the GUI. This practice assumes that we are the root user on DOM0, and we are. And we're going to view the network configuration on DOM0 using the ifconfig command. And the first interface, bond0 up here, has an IP address which will be different from yours. But you will have all these bridges, VIR, BR2, 3, and so forth. And those will be similar. We have 0, which is on the 192.0.2.1 network, and then VIR BR1 is on the 192.168.1 subnet, and 2 is on 2, and 3 is on 3. And the bonded interface that we create in this practice are also going to be on the 192.168.2 subnet, this one right here. So now step 2 says to log into host 02 by using VNC Viewer. I'm going to use a little bit different command than this one. You don't need to provide the port number. You can just say XM VNC Viewer and then the name of your virtual machine, which is host 02, and we're in. It's a little easier than all these steps here in step 2. We're going to click the Oracle student, and then we'll be prompted for the password, and the password is Oracle. So Oracle student, password is Oracle. And then we're going to open a terminal window and SU to root. And again, the password for root is also Oracle. So right click, open in terminal, SU dash, and the password is Oracle. So step 3, we'll view the network interfaces on host 2 by using IPADDR. And we'll note that 0 has an IP address and ETH1 has an IP address, but 2 and 3 do not. ETH2 and ETH3 do not have IP addresses. And these are the ones that we're going to use in this bonding practice. Use an ls command to view the configuration directory for the Ethernet interfaces. So that's etc sysconfig network -scripts, and you can see that there's an ifcfg file for ETH0 and for 1 and 2 and 3. So each of these interfaces has a config file. Use the nmcli con command to view the network connections. And you can see they're all here, all 4 of them, ETH0, 1, 2, 3, 4, but 2 and 3 do not have are not associated with a device. Okay, it says that there. And now in step 4, we're going to use the GUI to configure bonding. So select the GNOME network area to display the following. So click up in here and display this. And then we can select any of the Ethernet entries, for example, ETH1 to access the wired settings options. So we'll select ETH1 and then access the wired settings options. And we get this window here where we can add a new interface. The wired setting option displays the network settings GUI. So click the plus button to add a new connection type. And the Add Network Connection window shows up, and we're going to click Bond to add a bonded interface. So from here we can just say add, click add plus, choose bond, and now we're going to add a bonded interface. The following window appears. The default connection name is bond connection 1, and we can see that is the case, bond connection 1. The default interface name is bond 0, and that is also the case here. We can click add to add the slave interfaces to the bond. So I'm going to click the add, and then the following window appears. I'm going to accept the Ethernet selection and click create to display this window. So I'll click add, and I'm going to accept Ethernet, and then I'll hit create, and then I have the slave editing bond 0 slave 1 window. From here I can choose my Ethernet devices. So click the down arrow on the device MAC address to display the available devices. And then we're going to select ETH3 and click Save. So I'll click the down arrow, I'll click ETH3, and I'll click Save. And now we have one slave in here. And the next step is just basically to repeat that again and add a second slave. So click Add, click Create, click the down arrow. This time we're going to select ETH2 and click Save. So Add, accept Ethernet, Create, display the devices, and select ETH2 this time and hit Save. Now we have our two slaves in here. Going on down here, it says click the down arrow on the mode prompt to display the available modes. The list of modes appears. We're going to select active backup. So let's do that. Select mode, and you'll see all the modes that are available. And we're going to select active backup. And then you see that some of the prompts change. We now have a primary prompt when active backup is selected. You can designate an interface as primary to make it the active slave when you're using active backup mode. We, however, are not going to specify a primary interface, but you can also see link monitoring, monitoring frequency, link up delay. All these are parameters that you can tune. So we're just going to, now we're going to set the IPv4 addresses for this bonded interface. So hit the IPv4 tab and then choose manual, click add, and our address is going to be 192.168.2.12, netmask 24, no gateway. So click the IPv4 settings and manual, and then add, and our address is 192.168, 2.12. 2.12, netmask is 24, no gateway. So our window appears as shown here in the practice. Click Save, and scroll up and hit Save. And now our bonded interface appears here in our window, the network settings window. Click the X to close this. And now we'll view the network interfaces on host 02. You run the ipaddr command. And you see that, as it says here, the new bond 0 interface is listed. It includes master and state unknown. So here's the bond interface. It is master, and the state is unknown. Okay. ETH2 and ETH3 now include slave and master bond 0. So 2 is now slave and also master bond 0. And 3 is also slave and master bond 0. And you also notice that all these have the same MAC address. 0402, 0402, and bond is 0402. The bond 0 interface is listed as entry number 6 in this example. Yours might be different. Actually, ours is different. Ours is 8. Yours could be also different. Use the ls command to view the etc sysconfig network scripts directory. Note that there is a network configuration file for the bonded interface. There are also config files for the 2 slave interfaces. So let's cd into that directory and ls, and you'll see here's our bond ifcfg file, and then an ifcfg file for each of our slaves as well. Let's use the cat command to view the bond file. And it says note bonding ops mode is active backup, which we chose. These are all the link delays, up, link delay down, link delay up. We saw that on the window when we set this up. Link monitoring frequency. We can see our type is bond. It is the master. There's the IP address that we assigned it, the net mask, the name of the connection. Right. Use the cat command to view the contents of the slave files. So there's slave 1. There's the device. The master is bond 0. Slave is set to yes. And the same way with slave 2. The device is ETH2 for this one, ETH3 for this one, but master is bond 0 and slave is yes in both of these files. We can run the nmcli command to view the network connections. And you see now you have a bond connection and the 2 slave connections for ETH2 and ETH3. We saw, however, the state was unknown, so we have to set that up. We have to bring that up, and you just run this command here, nmcli. And we want to run up, and then quote the name of the connection. And now if we run ipaddr again, you can see that the state is up, which we just did right there. Do not log off. You can use this in subsequent practices. If necessary, open a new terminal window on DOM0. So let's go back to DOM0 and let's open up another terminal window. And we want to become root on this guy. In practice 13.2, we're going to configure network bonding from the command line. In this practice, we log into host 04 by using SSH. We view the network configuration on 04, and we configure bonding on 04 from the command line. It assumes we are the root user on DOM0, and we are. From DOM0, use SSH to connect to host 04. So I'm going to SSH. I'm going to use the IP address. I'm not sure if the host table is set up. So we're on host 04. View the network interfaces on 04 using the ipaddr command. So you can see that 0 has an IP address, 1 has an IP address, 2 and 3 do not, however. ETH2 and 3 do not. And these are the 2 interfaces that we're going to use to create our new bonding connection. So ETH2 and 3 do not have IP addresses. We'll use the ls command to view the etc sysconfig network scripts directory. And you'll see that each of the four ETH0, 1, 2, and 3 and all have config files in this directory. We can use the nmcli con command to view the connections. And each of these four Ethernet devices appear in the list. However, 2 and 3 are not associated with a device. You see there's nothing over here for 2 and 3. So 2 and 3 are not associated with a device. And now we're going to use the nmcli utility and configure bonding from the command line. So it's nmcli con add, and then you give it the type bond, give it a name, con name bond 0. You use the if name bond 0 to specify the interface. Use mode and then specify a mode, active backup in our example, and then IP4 and then the IP address insider notation to specify an address for the bonded interface. So here's the complete command. So we'll do nmcli con add and then type bond and then connection name bond 0 and then the IF name is also bond 0. And then the mode, we're going to set this to active backup. And then finally the IP address, insider notation 192.168.2.11. IP4 192.168.2.11/24. Make sure I got that right. IP4 192.168.2.11 and success. Now we'll do the similar command to add the bond slave connection types. We'll first do for ETH2, and the bond master is bond 0. So here's the command. So it's nmcli con add, type is in this case bond slave. And IF name in this case is ETH2. And master is bond 0. And success. And we want to do this again for ETH3. So the command is virtually identical. We're just going to change ETH2 to ETH3. So I'll just up arrow, change that 2 to a 3. And success. And now we can use the nmcli con command to view the connections. And you'll see that we have our bonded connection and our two slaves, ETH2 and ETH3, associated with the devices. We can ls our etc sysconfig network scripts directory. We'll see that we now have config files for the bonded interface and for the two slaves. You can look at those files. Let's start by looking at the bond config file. Sorry. Let's go into that directory. And so this is our bond file. So device is bond 0. There's the mode, active backup. Type is bond. It's bonding master, yes. The IP address, we gave it the net mask, the subnet, or the net mask prefix 24, name, so forth. And now we can also look at the slaves. Use the cat command to look at the slave files. We'll look at 2 first. So the name, the device is ETH2, and master is set to bond 0, slave is set to yes. We can look at 3, and it's very similar. Device is 3, but master is bond 0, slave is yes, just like for this file. So we can use the IPADDR command now to view the network interfaces. And we'll see that 2 is a slave now, the word slave, and it's got master bond 0. 3 is the same, 3 is a slave, master bond 0. And then down here is bond 0. One thing you can note is they all have the same MAC address, 34, 34, 34. Bond 0 has a IP address, we gave it. The state is unknown, however. So we need to bring that up. We use the nmcli utility to bring up bond 0 by running that command. So nm con or connection, you can spell it out, up bond 0. And now if I run the IPADDR, you can see that the state is now up, whereas before it was unknown. Do not log off host 04. You use it again in subsequent practices. In practice 13.3, we're going to work with these bonded interfaces. In this practice, we'll test connectivity between the interfaces on host 04 and 02. We'll explore the sysclassnet bond 0 directory. We'll change the MII monitoring frequency on 04. We'll test for slave failover on 04. And then we'll remove the bond and slave connections on host 02 by using the GUI, and we'll remove the connections on 04 by using the command line. Assumes that we are the root user on host 04 and 02, and that the bonded interface on 04 has an IP address of 192.168.2.11, and the bonded interface on 02 has an address of 192.168.2.12. So first, step 1, we'll test connectivity between the interfaces. So from host 02, we want to ping the bonded interface on 04. So we're going to ping 192.168.2.11 from host 02. 192.168.2.11, and we can see that the network is reachable. Let's run the netstat-r to view the route table. And you can see that that network, 192.168.2 network, was reachable through bond 0. Now let's do the same thing from host 04. Let's ping 02. So from 04, we're going to ping 2.12. So host 04. And it is reachable. And we can run netstat-r to view the route table and see that the 192.168.2 network was reachable through bond 0. Now let's view the contents of sysclassnet bond 0 directory. Each network interface contains a directory in sysclassnet. From host 04, we're going to cd into that directory. We'll look at the directory, and we'll note that bonding masters is a regular file. We'll cat that, and we'll see that the entry in there is the actual name of the bond. So we're going to do this from host 04, cd to sysclassnet. We'll do an ls-l, and we see that there's directories. They're actually symbolic links for each one of the interfaces, but there is a regular file called bonding masters. So we can cat that and see that contains the name of the bonding connection. Let's cd into bond 0. ls, the number of files in here. Let's look at a few of these. Let's first look at oper state. And it's up, so the bond is up. And let's look at the address. And there's the MAC address of the bond interface. We can view the U event. And it's 6 in our example. Yours might be different. Let's cd into the bonding directory. And do an ls. And see there's a number of files in there. Let's view some of these. We can view which one of the slaves is active by doing cat active slave. And ETH2 is the active slave in this bonding connection. We can view the mode. And its active backup is the mode. And we can view the slaves. ETH2 and ETH3 are the slaves. We can view the MII link monitoring frequency in milliseconds. And it's 100. We can view the MII status. And it is up. We can let's change the monitoring frequency now. On host 04, we're going to use the VI command to edit the network scripts ifcfg bond 0 file and change the bonding ops setting to 120. So let's VI on host 04. We're going to the bond 0. Okay, and now we're going to change. We're going to set the value to 120 rather than the default, which was 100. So we need to quote this since there's a couple entries now. It's MII mon equals 120. Make sure I got that right. Looks good. Save it. We need to use the nmcli command to reload all connection files from disk. Network Manager does not monitor changes to connection files by default. You need to use this command to tell Network Manager to reread the connection profiles from disk whenever making a change. So we'll run this nmcli con reload. And then we need to, we're going to bring down the bond 0 connection. So let's nm. And we brought that down, successfully deactivated. But it says stopping the master also stops the slaves. So now we want to bring the slave up. So we want to do up. ETH2. Reverse the order. I think I just needed to run it again. Now bring the bond up. Okay. And now we can cat this file again. I believe it was, which one was it? The Bang 208. We're in the wrong directory, sorry. So now you can see it's set to 200. We had to make the change here. Then we had to reload the files from disk, and then we brought the bond down, and then it brought everything up. Brought the slaves up, then brought the slaves up, and then brought the bond up, and then the change had taken effect. Let's test for slave failover. So the active slave in active backup mode is stored in the active slave file. You can also determine the active slave by viewing the proc net bonding bond0 file. On host 04, use the cat command to view the active slave file. So let's view that. And ETH3 is currently the active slave. In this, it's different from what's in my lab, but that won't matter. 3 for us. We'll use the cd command to change to this directory. And we'll do an ls. You'll see bond0 is there. We can cat that. And this shows the active slave is ETH2. Ours says the active slave is 3, which confirmed the contents of this file. So the lab says 2, but ours says 3 in both places, and that's all that's important. And what we're going to do is change it from 3 to 2. The lab, however, is going to change it from 2 to 3, but we're going to change it from 3 to 2. So we're going to bring down, instead of bringing down 2, the active is 2 here, but for us it's 3. So we're going to bring down 3 rather than 2. We're going to say IP link set dev, IP link set dev device ETH3 is down. That's currently our active one. So we're going to bring down the active one. Okay. And hit enter. And then we can show the state of it. Just show ETH3. And it shows that it's down. Okay. And we can look at the var log messages file. And note the bonding messages. ETH2 is disabled and ETH3 is active. Ours was just going to be the other way around. So 3 is disabled and 2 becomes active. And so so here we go, making 2 the new active one. We brought 3 down, and now 2 is the active one. Cat the bond file. We now see that the active slave is 2, whereas before it was 3. So it automatically failed over to the other Ethernet device that was part of the bond, which is the whole purpose of bonding. Let's view this file here. Use the cat command to view the active file now. And now it's 2, which is what we would have expected. So now we're going to remove the bond and the slave connections from host 02. Begin by using the network settings GUI. Complete removal of the connections by using the command line. So on host 02, we're going to select Application, System Tools, and Settings from the GNOME menu bar. So I'll go back to host 02. and we're going to do Applications, System Tools, Settings. And then we can, from the All Settings, select Network. So we'll select Network. And then we're simply going to, with the bond interface selected, click the minus button to remove the connection. So select this, hit the minus button, and it's gone. Click the X to close the window, and do the LS to view the contents of sysclassnet. And notice there's no more bond 0 directory. The directory no longer exists. There is a bond masters file, but it's empty. So we'll look at that. So it is empty. It's empty just by deleting it from the GUI. And we'll look at the procnet bonding directory also. And it is empty as well. We can run the nmcli icon to view the network connections. And our bond is gone, but our slaves are still here. Okay, the bond connection no longer exists. The slave connection's still here, but are not associated with the device, as you can see. Neither one of these are associated with the device. So we can use the IP link command to view the links. And notice there's no bond anymore. Bond 0 no longer exists. 2 and 3, ETH 2 and 3 no longer include slave or master, and they have their original MAC addresses back. So 2 is no longer a slave master, and it's now 302 for a MAC address. 3 has its 402 MAC address back, and the bond interface is gone. Let's look at our sysconfig network directory. Network scripts directory. We see that we still have the config files for the slaves, but the bond interface file no longer is here. We can use the nmcli command to delete those slave connections. So let's delete these. We have to quote these since there's white space. And then 2, get rid of it. And now they're gone. They don't show up in that output anymore, and they don't show up in our network scripts directory as well either. So we're back to the original 4 ETH interface files in this directory. Now let's remove the bond and slave on host 04. We're going to use the command line to remove these connections. So on 04, use the nmcli con command to view the network connections. So let's go to 4. So everything's here, bond 0, our 2 slaves. And then we can use the delete command to delete all these. All right, so we'll run this one for the bond, and then we'll get rid of the slaves. Bond 0 is gone. Bond slave ETH2 is gone. And 3 is gone. Right? They no longer show up. We can look at our network scripts directory. And our interface, our configuration files for our bonding connection and our slaves are gone. We can run IP link and see that our MAC addresses are back for 2 and 3. and the bond interface or the bond connection is gone. We can look in and our bond 0 directory is gone. The contents of the file, the bonding master file, is still there, but it's empty. Okay. And then finally, we'll list the procnet bonding directory. And it's empty as well. In practice 13.4, we're going to configure 802.1q VLAN tagging by using the GUI. So in this practice, we will ensure that the kernel module is loaded on 02. We'll use the network settings GUI to configure VLAN tagging, and then we'll review the network configuration. This assumes we are the root user on 02, and we are. So, step 1, on host 02, load the VLAN 8021Q kernel module if necessary. Use the lsmod command to view the loaded kernel modules. Pipe the output to grep, search for 8021Q. If it's not loaded, use the mod probe command to load it. So, lsmod grep 8021Q. It's not loaded, so we're going to load it. And we can confirm by running lsmod again. So we've loaded the kernel module for VLAN. And we're going to use the network settings to configure VLAN settings. So we're going to open up the GNOME notification area. Right? We can select any of the Ethernet entries, for example, ETH1, and to access the wired settings options. So let's do ETH1, wired settings, and we get to this window. And now we just want to click the add button, the plus button, to add a new connection type. The add connection window appears, and we're going to click VLAN. So plus and VLAN. And then our editing VLAN connection window appears. The default connection name is VLAN connection 1, as we can see. We're going to update the screen as follows. We're going to change the connection name to VLAN-ETH0.100. So we're going to click the parent interface and select ETH0. We're going to change VLAN ID to 0, and we're going to change the VLAN interface to ETH0.100. So VLAN-ETH0.100. Parent interface, we're going to select ETH0. Change the VLAN to 100. And change the VLAN interface name to ETH0.100. So our window should look like this, and it does. We'll click the IPv4 settings to assign an IP address. It's going to be 192.168.100.2. So IPv4, we're going to go manual, add 192.168.100.2. .100.2. Net mask is 24. No gateway. So that looks right, and then we're going to click Save. The VLAN interface now appears in the network settings window. All right. We'll click the X to close this window. View the network interfaces on host 02. Use the IP ADDR command. So now we see the ETH0 device exist, right? And that the ETH0 100 MAC address is the same as ETH0. So it's 0102 for this guy. And ETH0 is also 0102, same MAC address. Note that the IP address is associated with this device. So we have an IP address associated with this device. Use the nmcli dev command to view the network devices. And note that ETH0.100 is associated with the VLAN-ETH0.100 connection right here. So this device is associated with this connection. We use the nmcli con to view the network connections. And we see that our device shows up with our connection, our VLAN connection. And there we use the ls to view the network scripts directory. And we see that there is a config file now for this device, for this connection. Let's have a look at that. And we'll notice that the device is ETH0.100, but the physical device is ETH1. So it's VLAN, yes, type VLAN. Device is ETH0.100. The physical device is ETH0. The VLAN ID is 100. That's the IP address we gave it, the name. In practice 13.5, we're going to configure 802.1q VLAN tagging from the command line. In this practice, we're going to ensure that the kernel module is loaded on host 04, and then we'll create a VLAN interface on host 04. This assumes we are the root user on 04. On 04, we're going to check to see if the VLAN kernel module is loaded, and then load it if necessary. So I'll go out to host 04. We'll do a ls mod and grep for 8021q. It's not loaded, so we'll do a mod probe to load it. And rerun the ls mod command to verify that it's loaded. And now we're going to create an interface and view the results. We're going to use the nmcli con add command. The type is going to be VLAN to specify a virtual LAN interface. The connection name, we'll give it VLAN-ETH0100. We're going to use if name ETH0.100 to specify the internet interface to bind the connection to. We'll use dev ETH0 to specify the parent device. We'll use the ID100 argument to specify the VLAN ID, and then finally IPv4, and we'll give it an address. So here's the complete command. So it's nmcli con add, and type is going to be VLAN. Connection type is going to be the connection name VLAN-ETH0 .100. IF name is ETH0.100. And device is ETH0, the physical device. And the VLAN ID is going to be 100. ID is 100. And the IPv4 address will be 192.168.100.1/24. So let's make sure I entered that correctly. I believe I did. Success. All right. Now we can view the information that we just configured. So IPADDR. We'll see our new device down here with its address. And it should have the same MAC 104 as 0, which is 0104. 0104. And it has an IP address. We can view the devices, and it shows up. The device shows up associated with the connection. We can view the connections. Connection is associated with the device. We can look at our network scripts directory and see that there is a config file. Let's have a look at that. And you can see it's a type VLAN. I'm sorry, VLAN is yes. It's a type VLAN. The device, physical device is ETH0. The VLAN ID is 100. The IP address, so forth. In practice 13.6, we're going to work with VLAN interfaces. So we'll test connectivity between the VLAN interfaces on host 04 and 02. We'll use TCP dump to view tagged and untagged packets. We'll explore the contents of the sysclassnet ETH0.0 directory. And we'll explore the contents of the procnet VLAN directory, and then we'll remove the VLAN interfaces on 04 and 02. Assumes you're the root user on 04 and the root user on 02. And we are. The first thing we're going to do is test connectivity between the VLAN interfaces. From host 02, we're going to try to ping the VLAN interface on 04. And the IP address of the VLAN interface on 04 is 192.168.100.1. So we're going to run this from host 02. And this is host 02. And I'm logged in as the root user. And we're going to try to ping the VLAN interface on host 04. So that's 100.1. And it is reachable. We can use the netstat-r command to view the route table. And we see that that network, the 192.168.100, was reachable through the ETH0.100 interface. Now let's go the other way. From 02, let's try to ping the VLAN interface. I'm sorry, from 04, let's ping the VLAN interface on host 02. So we'll ping 192.168.100.2, and it is reachable. And again, we can look at the route table. And it also shows that this network was accessed or reachable through this interface. Let's use TCP dump now in step 2 to view tagged and untagged packets. First, we're going to observe traffic on the VLAN interface where you do not see VLAN tags. And then we'll observe traffic on the parent interface where you do see the VLAN tags. So on host 02, I'm going to open up a second terminal window. I'm going to use the SU command to become the root user. So host 02, let's open up a new terminal window, and I'll become root. All right. And now in this second terminal window, we're going to enter this TCP dump command. The -E option views the Ethernet header, which includes the 802.1q tags. The -I with this argument, ETH0.100, will sniff on the VLAN interface. So TCP dump. And -E, -I, and ETH0.100. Okay. And on this other terminal window, we'll ping host 04 again. Just to generate some traffic. Control-C after a few lines of output. In the second terminal window, we can now view the TCP dump command, the output of the TCP dump command. And note that you'll see normal traffic without any VLAN tags. So it's just normal ping traffic, ICMP traffic. There's nothing in here that indicates any VLAN tags. So now we'll press Control-C to terminate that. And okay, now we want in the second terminal, we're going to enter a different TCP dump command. We'll use the -E option again, but now for -I, we're going to use the ETH0 to sniff on the physical interface, and here we'll see the tags. Optionally use the clear command to clear the screen. Okay, let's do that. And let's run our TCP dump command again, but this time we're just going to sniff the physical interface. Right? So let's run that. And then we'll come back down here and run ping on our second window. To generate some traffic, and press Control-C after a few lines of output. And in the second terminal window, we can view the output of the TCP dump command. And now we'll be able to see the tagged packets with VLAN 100. So you can see VLAN 100 shows up in each one of these, or many of these. All right, press Control-C to exit the TCP dump command. Click the X in the upper window of the second terminal, so we're done with this. We'll close this. All right. Now let's view the contents of the sysclassnet file. Each network interface again contains a directory in this directory. So host 04, we'll use the cd command. We'll see that we have a directory for all of our interfaces, including the ETH0.100. We can use the cd command to change into that directory and then do an ls. See, there's a number of files in here. Let's look at a few of these. Let's look at the state. And it's up, which we expected. Let's look at the address. And there's the address, the MAC address of the interface. We look at the U event. And it might be the IF index value is different. It's 6 here on our system, but it's 8 in the practice. You can view the procnet VLAN directory. And you'll see there are a couple files in here. Let's use the cat command to look at the config file. And the sample output is shown. Egress traffic begins inside of the network and proceeds through its routers to a destination outside of the network. And then ingress traffic originates from outside and proceeds toward the network. Let's look at the E file to see that type of ingress and egress stuff. Okay. Let's now that we've used it, let's remove it. So first we're going to remove it on host 04. Let's view the connections. And we can use the delete command to remove that connection. And that was success. We run our connection command again. It no longer appears. We can look in our network scripts directory. And the VLAN interface no longer appears. We can use the IP link command to show our links. And ETH100 device no longer appears. We can use the ls to view the contents of class net. And our ETH0.100 device or directory no longer appears. We can look at the procnet VLAN directory. And our config file is still here, but our ETH0.100 file no longer exists. If we cat the config file, it no longer has any information in it other than a header. Okay, now let's remove the VLAN interface on host 02 using the GUI. We did it on 04 from the command line. We'll do it on 02 from the GUI. So we'll go access the network settings again, like we did in a previous lab. Application System Tools, Settings, Network, and then select the VLAN entry and click the minus button to remove it. The interface is removed without additional confirmation needed. You can close this window. And let's run nmcli to show that it no longer exists. No more VLAN interface or connection in here. Let's look at our network scripts directory. And there is no more config file for our VLAN interface. We can run IP link, and we see that the ETH0 device no longer exists. We can look at our sysclassnet and there's no more ETH0.100 directory. Okay, and finally we can look at the procnet VLAN directory, and our VLAN entry is gone. We cat the config file. All it has is header information. Okay, now in preparation for the next practice, we're going to power off host 04 and host 02. So I'm going to do system power off on 02. And also on 04. And I don't believe host 01 is running. I can just run xmlist. And none of my virtual machines are running at this point. Practice 1317, we're going to configure a site-to-site VPN. So in this practice, we'll explore and start VPN-host1 and VPN-host2 virtual machines. These machines were configured specifically for this practice. We'll generate an RSA authentication keys for these two virtual machines. We'll update the etc ipsec.com file on both of these virtual machines. We're going to stop the firewall service on both of these virtual machines. We'll start IPsec on them both, and then we'll verify connectivity between the machines, and then we'll shut all this down. So the assumptions are that we are the root user on DOM0, and we are. Host 01, 02, 04 have all been shut down. We have no virtual machines running right now. VPN host 1 and VPN host 2 exist, and the following describes their network configuration. So there's a graphical, or there's pictorial description of the configuration, but we're going to go in and look at the config files for these virtual machines and to try to explain this a little bit better. So explore and start the VPN host 01 virtual machine. So from DOM0, I'm going to cd into this directory. Okay. And we're going to look at the vm.cfg file. And we can see that the interface on BR0 is ETH1, and it has an address. Well, we can't see the address, but we'll show the address in a bit. But there's three interfaces, and they're all on different bridges. All right? And that's really what this shows. And we'll show the addresses once I start this machine. So let's start it. So that starts the virtual machine. And now let's look at 02 as well. So cd to and you'll see also that there are three network interfaces, all on different bridges on this machine as well. Okay, and we'll look at the addresses when we start it up. But the interface, note that the interface on bridge 3 is ETH2, and ETH2 on host 02 is on a different bridge and a different subnet than host 01. So let me open up another terminal window. So you can see there's interfaces on bridge 0 on both machines. There's interfaces on bridge 1 on both machines. But on host 02, this interface, the third Ethernet interface, is on bridge 3, whereas on host 01, this third Ethernet interface is on bridge 2. So let's start it. So we have both of our machines running now, both of our virtual machines running. We can connect to VPN host 01 by using VNC Viewer. So let's just say XM VNC Viewer VPN host 1. Oh, I need to be root. So we connected to host 01. We're going to log in as the Oracle student. Password is Oracle. And the GNOME desktop appears. We're going to right click to open a terminal window. And then we're going to become root. Okay, first thing we're going to do in step 4 is generate a new RSA authentication key. So we're going to use the IPsec new host key command to generate the key. The -- config-dir option specifies the Network Security Services config directory where the certificate key and databases reside. The -- output option is mandatory. This command might take a few seconds to complete. So let's run it. IPsec new host key -- config-dir /etc IPsec.d -- output /etc IPsec.d, and we're going to call it www.example.com.secrets. Okay, make sure I got that right. So IPsec new host key -- config-dir etc IPsec.d -- output etc /etc IPsec.d /www.examples.com.secrets. Press enter. It will take a few seconds to generate this. So it says generated RSA key pair using the NSS database. Success. So now we want to log into host 02 by using VNC Viewer. So let's do that from another terminal window. And we want to come in as Oracle and open up a terminal window and become root. Make these a little smaller. Okay, so we're logged into VPN host 1 here. We've generated our key. We're logged into 2 here. And we want to, we're root, and now we want to run this to generate a new RSA authentication key for this host. IPsec new host key. So it's the same, basically the same command we just ran on VPN host 1. So it's IPsec new host key --config_dir /etc/ipsec.d --output /etc/ipsec.d www.example.com.secrets. Okay. Make sure I got that right. IPsec, new host key, --config_dir, etc ipsec.d --output /etc ipsec.d www.example.com.secrets. And it generated the key. All right. So now we need to put the appropriate keys in the ipsec.com file. So on VPN host 01, we're going to cd to the etc directory. Okay. And we're going to show the key now. So it's IPsec show host key --left. IPsec show host key --left. And there's our key. All right. Select the left RSA key string and copy it into the buffer. So highlight the string as shown with the string highlighted, select edit copy from the terminal window. So we need to select from left RSA all the way to the end and copy it into the buffer. So right here to there. And we'll do an edit copy. That's on VPN host 01, right? So now we want to vi ipsec.conf. Okay. And we're going to paste the contents at the end of the file. So position your cursor on the last line of the file. Press the lowercase o to get into insert mode and open a blank line. Select edit paste. Press escape and save it. So we're going to go to the end of the file. A little o to open a blank line. Edit, paste, escape, save. All right. So now on host 02, we want to show the right key. So the command is IPsec show host key --right. And there's the right key. And now we want to highlight, select the right key, and highlight it and copy it into the buffer. So we'll select it and edit, copy. And now we're going to just create a file, a temporary file called write, and paste the contents into that. So vi write, press the lowercase I to get into insert mode, paste it, hit escape to exit insert mode, and save it. So vi write, I for insert, edit, paste, escape, save it. Now from host 02, we're going to use SFTP to copy the file. We can actually use, we'll do what it says. We'll use SFTP. So SFTP 192, we could use SCP, was all I was thinking. .0.2.111. Yes. Oracle. Okay, we got an FTP connection. So now we just want to put write. And it's uploaded. And now we can quit. Okay, so that file is now on host 01 as well. And the next step here is just to concatenate those. So we're back to host 01. We want those keys in the same file, right? So we're going to concatenate IPsec and the root write file into a single file. So first thing we're going to do is move this file, and so I'll say move IPsec comp to IPsec.bak. Okay, so I moved it, and now I'm going to concatenate that file along with the write file that we just FTP'd over and redirect the output out to IPsec. Okay, so we've just concatenated those two files is really all we've done. All right. Now, the file now includes these key strings at the end of the file. Okay. So if I do a cat, you can see those strings are at the end of the file. Here's the left one, goes to there, and there's the right one, goes to there. So complete the site-to-site connection configuration in this file on host 01. So use the VI editor and add CONN site-to-site and the left IP address information before the left key. Indent all lines that start with left. Do not exit. Okay, so we're going to VI. And we'll go to where it says include. Okay, and that's the original end of the file before we generated these keys. And so we want to open up a line here and put all this in. So it's CON, site to site, right? And then we're going to indent 1, 2, 3, 4 spaces, and left ID is 192.168.1.101. And left is the same IP address. And left source is 2.101, left source IP. And left subnet is 2.0/24. And then it says indent all lines, including the key line. So we can escape and go down one line and indent this, put I to insert. So all these lines have been indented, all right? And that looks right to me. 192.168.1, left equals 192.161, left source IP, left subnet. Okay. And now we need to go down at the end of this and do everything for the right side. So we're going to open up a line above, and indent 1, 4, 1, 2, 3, 4. And write ID equals 192.168.1.102, 192.168.1.102. Write equals the same IP address. Write source IP equals 3.102. And write subnet equals 3.0. Slash 24, I believe. Yes. And that all looks good. And then we also need to indent the key. So I'm going to hit escape and I, 1, 2, 4. All right. And then add the following two lines at the very end. So let's go to the bottom and open a line below it. And this also needs auth by equals RSA CIG SIG. And then auto equals start. Okay, save the changes. You can check the syntax by running this command here. So if there are no errors is good news. So let's run this /user libexec IPsec add con --config /etc IPsec .conf space --check config. And we hope we get no errors, and we got no errors. That's good. Now we can put this back. So we built the file on VPN host 1, but now we have to push it over to 2, so both hosts have the same file. So we'll do SFTP 192.0.2.112, 0.2.1112. Yes, Oracle. And now we've connected, and now we want to put ipsec.conf to etc ipsec.conf. It's over there now, so both have the same file. So we can quit. And now we need to enable IP forwarding on both of these guys. So we're on one. We'll do sysctl -w net.ipv4 so it's net.ip_forward equals 1. All right. We ran that command on VPN 1, and we need to run it on 2 now. So it's sysctl -w net ipv4.ip_forwarding. I guess it's forward. We need to stop the firewall service. We could add rules, as it says, to trust the IPsec protocols. LibreSwan requires the firewall to allow the following protocols, the following packets: UDP port 500 for the IKE protocol, UDP port 4500 for IKE net traversal, protocol 50 for ESP IPsec packets, 51 for AH IPsec packets. For purpose of this exercises, we're just going to stop the firewall service rather than add all these rules. So I'm going to stop it on VPN 1. Stop firewalld. And I'm going to stop it on VPN 2. Okay. Now I want to test connectivity before starting the IPsec service, just to show that it doesn't work until I start the service. So on 1, let's run the netstat -rn command. And you'll see that there is no route to 192.168.3. There's no route to 192.168.3. We can try to ping. Um, 3.102. And it's unreachable. Control C out of that. Okay. We can do the same thing on VPN 2. Run the netstat. And we'll see that there is no route to the 192.168.2 subnet. So we're trying to get to 3 from here. We're trying to get to 2 from here. Okay. In a secure tunnel. We can ping. We can try to ping 192.168.2. 2.101. And it's unreachable. Okay. So now let's start the service. And then we'll test connectivity. So on VPN 1, we're going to start the service. So it's systemctl start IPsec. We're going to start the service on 2, same command. And now let's check the route on 1. And we see that there is now a route to 3. Before we didn't have a route to 3, but now we do. Okay. And let's try to ping now. Now we can ping. Before we couldn't. Okay. And let's go to 2 now and see if we have a route to 2. And we do. Before we didn't. We just had a route to 3. We didn't have a route to 2. We can try to ping again. And now ping works. Before it didn't. Okay. From host02, use the IPsec auto status command to view the current connection status. So that's IPsec auto status. And we can say, it says note the ESP algorithms supported, note the IKE algorithms, note the connection site lists, site to site. So we got the site to site here. Let's a lot of information here. Here's the IKE algorithms, the ESP algorithms. All of these protocols, ESP, ESP. Okay. Here's the beginning of the output of that command. Right. Okay. So let's shut all this down now and power these machines off. So shut off 2. And shut off 1.